Okay. Hello again, everyone. So we're just going to continue along now. So we are up to chapter 5. And what we're going to do here is we're going to explore how to look at, let me just quickly move some things around on my computer. So just as we did yesterday, hopefully you can see my screen now. But just as we did yesterday, I encourage you to please have your cameras on if you can. It's always nice to see people's faces, although I'm not going to enforce that if you would rather not. It just gets very lonely if I'm the only one with my camera on. The other thing I'll ask is if you want to ask a question at any point, please feel free to just shout into the microphone. So it's easier to get my attention if I can hear your voice compared to if I have to look at the chat and look at the window again. So you're very, very welcome at any point to sort of poke me by using your mic. And that includes when I'm sort of asking any questions. But anyway, let's have a look at this section here. So what we can see is if we have a so we've got our mars.txt file, right? And if we can add a line to a new line to our mars.txt file, so an ill-considered change, right? And then we use this command git diff head mars.txt. It's going to give us the difference between what is called the head and the file. And you can see here in the log that it outputs, there's a little plus icon next to that line. Okay, so that indicates that we've added that line here. Now, what that does, again, is it compares something called the head, which is the most recent commit of the working directory. And we're comparing that most recent commit to the contents of this file as it exists in the directory. And it finds that that change has been made. Okay, now, if you didn't put head in, it would basically do the same thing. However, you can manipulate this a little bit better to, let's say you don't want to look at the most recent commit, you want to look at maybe a couple of commits back. So you can add a tilde character with a number, and the number is essentially the steps of the commits before the most recent one. So if you're doing tilde1, it means the commit that is one step before the most recent commit. Okay, so if we do git diff head tilde1 mars.txt, then it's going to give us this output, but because this was the line we added in the comment just before that, now we're going to have another plus sign here. Okay, does that make sense? You can do this with any steps that you like. So you can do head 1 or head 2, head 3, and you can see the further numbers you put in, the more pluses you get, just referring to how many steps back we're going. Okay, so now we have at 3 steps before the most recent commit, we have all these changes have been made. All right, now there's another thing you can do, which is using the git show command, which not only shows us the changes, but also tells us what the commit message was. So for example, if we do git show head 3 mars, it will show us that the difference between those two files is essentially that. And if you look here, we've done diff head 3 mars. That was the line that we added here at that commit. And these are the lines that are the difference. Okay, so when we do show head3 Mars, what we get is the changes as well as a comment message. That's quite useful as well. Okay. Now, you can also refer, instead of using the head as like an identifier, you can also use the comment ID. So the way to do this is, if you were to go into your Git log, so if you type in git space log, it will show you the history of your commits as well as the comment identifier. Okay. So if you put that in instead of head, it will give you basically the same thing. So this is the identifier for the very first commit. And if you do the difference between that first commit and the file that exists, it will show you that that was the first thing you had in the file, and these are the changes. Exactly the same concept. However, this is a very long string of characters, so you can actually cut it down quite considerably just by using the first couple of characters. So here, the first 7 characters will give you the same thing. So you don't need to actually type out this whole thing. You can just pick out the first 7 characters, and that does the same thing. Okay. So what we do now is, let's say we want to use git status. What's going to happen? It's going to tell us we've modified that file by making that change here, but it hasn't been added to the commit. Okay, so it shows us that it's been modified, but it's not actually in the staging area yet. Okay, so let's go forward a step and look at the git checkout command. Let's say we didn't like the change that we'd made. For whatever reason, that change was probably a bad one, as you can see, an ill-considered change. So we want to maybe get rid of that. And the way we can do that is with the git checkout command, right? So what we can do is go git checkout head mars.txt. And what that does is it will take the version of mars.txt that is contained within the most recent commit and actually restore that to the file. Okay. And again, you can do that using either head or head tilde1 or head tilde2, or you can use the comment identifier. Okay. And that, if you were to use that command and then look at the contents of mars.txt, I will answer that question in a second. Then you will see that that line that we added just before is gone. Now, in terms of how many characters you need for the ID, I'm going to say usually 7. The reason I'm saying that is because, I mean, it's a very long string. It's a unique identifier, and you want it to be unique. So you need to have enough characters in there for it to be truly unique, but you also don't want it to be you don't want it to be so short that it matches to anything. If you were to copy 9 digits, it would still work fine. All right. So that's however many couple of digits at the beginning you want to copy. Probably like 2 or 3 is not enough, right? So I hope that sort of addresses that question. Now, what we wanted to do, if we use, so here we're doing checkout head. If we go and use the checkout from I think that was the first commit, we can do the same thing. And that now, if we check out that file and we look at the contents, we only have the 1 line, and that's because we've checked out the file from an even earlier commit here using the comment identifier. Now, if we look at git status, what will that tell us? It will, even though we've restored the changes to the file, they still are not in the staging area, right? So they haven't been pushed as a new commit. So they are in the staging area, but they haven't been pushed as a new commit. So if you wanted to revert it, again, so you've just done this, you've checked out that file from that identifier, you can always put it back to the way it was by just going and checking out from the head, which is obviously your most recent comment. Now, a couple of things about head. We are doing git checkout identifier and then the file. But if you were not, if you didn't put in the file name, Git will do something a bit funny, and it will warn you that you are in a detached head state. What that means, so head kind of refers to the most recent commit. If you were to enter a detached head state, what it will allow you to do is sort of to go back through your history and to make changes or discard particular comments or commits. So as the way we've seen Git working so far is we have one commit to the next, and so you have a bit of a chain. And the most recent commit is anchored as your head, right? If you detach your head, that means you can go back through the path and sort of like create changes back earlier in the chain, and that can get a bit funny. That you can, there are some valid reasons for you to want to do that, for sure, but most of the time, especially in your probably general usage, you probably want your head to be attached. So probably you wouldn't want to make any changes when you're in a detached head mode. So if you ever encounter this detached head mode, then you can reattach your head by just saying git checkout main, right? And that will put your head back on. All right. Does that sound agreeable to everyone? I'm going to just take that as a yes. Okay. So now, let's say I've made a comment, and I don't like my comment, and I actually want to go back a step. What is my command going to be? Is it going to be git checkout head, my file, or is it going to be what is it going to be? If I've already made the commit, then that commit, the most recent commit, will be the head. So if I've already made a commit, then rather than do git checkout head, my file, I will use git checkout head ~1, my file, because if I've checked it out already, sorry, if I've committed it already, then I don't want to restore from the commit because that's where the mistake is. I want to go one step back. All right, so that's what we're looking for here. And hopefully this makes sense to you, but just a little bit of an image about what's going on. So the most recent commit is our head, and then underneath that, the different files. So if I were to git checkout with head ~1, that would take that would restore from head ~1 to the file that it currently exists in the working directory. Okay, so hopefully the way that this chain makes sense is more intuitive to you now. Okay, so it's just a chain of commits, and you can actually go back through the chain to say, bring me back the file that I had at this particular commit. All right. Now, what do I need to tell you here? Yeah, so you can use checkout. So the way that checkout works is that it is going to affect the files that actually exist in your directory. Okay, and it will bring back the copy that exists in a particular commit, right? So whether you've added or deleted things, it will bring those back. Okay, so then once you've done that, then you can actually make a new commit once you've brought back the particular changes that you need, right? I'm going to just skip past that. Okay, so let's go through this example. So Jennifer has made changes to the Python script that she has been working on for weeks, and the modifications she made this morning broke the script and it no longer runs. She has spent an hour trying to fix it with no luck. Luckily, she has been keeping track of her project's versions using Git. Which commands below will let her recover the last committed version of her Python script called datacruncher.py? What do you guys think? Is it 1, 2, 3, 4, or 5, which is both 2 and 4?
5.
Yep, it is 5. So if she has not made the commit yet, and she wants to recover the last committed version of her Python script, then she can use head. And if she uses the unique ID of the last commit as well instead of head, that will work as well. Great. Now let's look at this example here. So Jennifer is collaborating with colleagues on her Python script. She realizes her last commit to the project's repository contained an error and wants to undo it. Jennifer wants to undo correctly so everyone in the project's repository gets the correct change. The command git revert, okay, so this is a new command, git revert, will create a new commit that reverses the erroneous commit. Okay, so the difference here is what you're doing with git checkout is you're retrieving a file from a previous commit, but what you're doing with git revert, okay, is you are creating a new commit that fixes the erroneous commit, okay? So let's say Jennifer wants to use git revert. What is a missing command here? And this is subtle, but what command should Jennifer have used there to look at the Git history? Git log, perfect. So git log will be able to show Jennifer the project history with the unique IDs that she can copy in order to revert the commit. Okay, so this is what the reason you'd want to use git revert is because if you use git checkout, you're going to restore the versions of the files to your directory. But if you use git revert, what you do is you actually push a new commit that actually goes back to a previous commit. Does that make sense? Git revert head. Okay, what would happen if you tried to use git revert head? Consider if you have already committed something, and then your head is your most recent commit, right? So if the error is in your most recent commit and you're trying to revert from your most recent commit, basically nothing is going to change, right? So that's probably not the way to go about doing that, okay? Because that's where it's been committed, and if you're trying to sort of restore it from that, there's no point. Is git revert the same as git checkout stage commit? Yes and no. And the reason I say that is because let's say you have made a change and then you stage that change and then you commit it. Then that most recent commit's going to be pushed, right? So what's going to happen there is it's a bit more work for you, right? Because what you'd need to do is you would need to actually check out the files one by one. So remember, when you're doing git checkout, you need to tell Git which file you are restoring. And considering if you have a large repository with many changes and you've got several errors, then you want to just restore that particular commit without having to like check out all the different files that may be problematic. Does that make sense? Okay. So let's have a look at this particular, just so we a little bit more familiar with what Git is actually doing. Let's have a look at this example here. So I'm going to add to my venus.txt file a line that says Venus is beautiful and full of love. And then I'm going to add that to my staging area with git add venus.txt. Okay, then I'm going to add another line. Venus is too hot to be suitable as a base to my venus.txt file. I'm going to commit the file with or I'm going to make a commit with the comment here, the commit comment message, and then I'm going to check out from the most recent commit venus.txt. What will venus.txt be in this case? Is it 1, 2, 3, or 4? What do you think? Okay, Adam, why is it 2?
So you only add the first line, beautiful and full of love change, and then you commit that, and then you check that out into the file. So you you don't keep the second line.
Yeah, absolutely right. So you've made that change and then you've added it. So even though you've added this text, that's not this change is not in the staging area because you've added venus.txt to the staging area at this point. So this doesn't get added to your commit. All right. So then if you revert from the most recent commit, it actually takes you back here because this change didn't get added to your commit because this change came after you added venus.txt to your staging area. Does that make sense to everyone? I'm going to assume yes. If I'm going too fast or if anything doesn't make sense, just let me know. Just prod me. Okay. So let's look at git diff head ~9 mars.txt. What's going to happen if I run this command? So like, let's say I've made, as we've done in the examples we've been looking at so far, what would happen if I did git diff head ~9 mars.txt? How many, so let's say we've made 4 commits. What would happen here? Yes, there'd be an error because we don't have 9 commits before the head. So it's going to be an error. This won't work. Okay. What if I were to do git diff most recent comment ID mars.txt? What's that going to show? That's going to show nothing. Presuming you haven't made any changes between your most recent commit and the file, then you're not going to see any changes. Okay, because there is no difference between the most recent commit and mars.txt, right? Just to respond to the question here. So would git revert head ~1 reverse the last comment you made? Yes. So if you've made a commit and then you used git revert head ~1, you would actually you would revert to the commit just before that. Okay. So let's have a look. where am I going? Okay, so git checkout. So as we've seen, we can restore a previous commit when unstaged changes have been made, but will it also work for changes that have been staged but not committed? What do you think? If I were to use git checkout and restore a previous version of a file from a previous commit, then if I what I would actually see is that change would be reflected in my staging area. So that is versatile in that way. Okay, so you wouldn't need to do git add again. All right, so let's look at the next part here, which so like we've been looking at a project here that has like 4 commits, but what if we have a giant project which has lots of commits, right? Then if we do git log, then we're going to have a very, very, very long list. So the problem with doing git log is that it just tells you the commit messages, right? What you want to do is, if you look at git diff, you will be able to see the changes to the file, right? But if you can combine those two things together, then, and you can see the commit messages and the changes to the file, that might help you find what you're looking for a little bit better. And the way to do that is to use git log --patch and then the file name. And what that will do is it will not only show you the differences, but it will also show you the commit messages. So we'll combine those two pieces of information. So you can look for the specific change that you're looking for, as well as going through the commit messages to make sure that that's the right one you're after. Okay. Now, with something like this, it is not going to work either, right? Because we don't have 9 steps behind us. Okay. But what it would do in theory, it would give us the log with the commits to any file that is a txt file. All right. So now we want to look at, we've made a commit, okay, but we don't want to, there might be an issue with it or something. We might have, that might contain an error, or we might have had a spelling mistake somewhere. We just want to fix that, but we don't want a whole new commit to be able to do that. And we can actually run just something called git commit amend, right? And let's say we made a change to our mars.txt file. Then what we would be able to do is, if we if we made that small change and we put that in our staging area, we could then do git commit -- amend. Now that will open up a new window that will prompt you to change the commit message. Okay. And so it will display your current commit message, and then you can edit that as needed to sort of indicate what has been updated in the commit. Okay. So then once you've done that, running the log will tell you, it will update the updated commit message. And then you can use the git diff head and head ~1 to show the difference between the commit that you have just updated and the commit previous to that. And it should show you that you've got the correct message. Okay. What do I need to take you through now? Are there any questions about any of that? Okay, we're just going to move on. The next thing you might want to do in Git is to ignore certain files. So I might have a directory, a Git repository, and it might have a number of files, and I don't want them to be included in my repository, but I actually do want them physically present in the directory. So can we tell Git that these particular files are not actually part of the repository? They just exist in the directory, but don't track them. Don't add them to a commit. We can actually do this with git ignore. So let's say that we have a couple of files, a.dat, b.dat, c.dat, and we also have a.out and b.out, right? And a folder called results, in which a.out and b.out live. If I were to look at git status, it's going to tell me that these files are untracked. And so we need to, typically we do git add to add them to the staging area. But I don't want them. Potentially, as it says here, these are backup files or intermediate files created during data analysis, and they're not needed to be in the repository. So what will happen? How do we get Git to ignore them? What we would do is we would create a file in the root directory of our Git project called .gitignore, and we would then go into it and add the list of all the files we want to ignore. Because we want to ignore all the .dat files, we can do *.dat. That will match any .dat file, so it'll ignore all of these. And then we also want to ignore anything in the results directory, so we add results as well. Okay, so now if we make that file, save it, and then type git status, it's going to be updated by telling us that we actually do have this, none of these are included, but we now have this .gitignore. Okay. Do we want to track that? Yes, we do. We actually want, if we're sharing a repository, we probably want all of our friends working on the repository to ignore the same things we do. So we actually can add the .gitignore to our commit. We can actually track that as well. Now, if you had a file that you ignored, so we're ignoring all the .dat files, but if I tried to add a.dat, even though I've already told Git to ignore it, it's going to tell you, hey, you told me to ignore this, but you want to add it. What's going on here? So it will give you a hint. If you really want to add it, you can use a git add -f and then the file. But this is just a reminder that you're trying to add something that you've already asked to ignore. Okay, so you can actually force it with the -f flag. You can also do git status --ignored to see all the things that are being ignored as well. Okay, and that's convenient. And so it tells us what is being ignored and what we're keeping track of. So let's say we had a folder in our repository called results, and within that results folder we had two folders, one called plots and one called data. How would we update our gitignore file to ignore just results/plots? Simply, we just include results/plots. That will just target that directory. Okay. Now, if we want to ignore all the .dat files except for final.dat, what would that look like? And this is pretty cool. You can do *.dat, which will ignore all the .dat files, but then on the next line, you would do the exclamation sign in front of final.dat. And that tells you ignore all the .dat files, but do not ignore final.dat. Okay, so that's another way you can update the .gitignore file. Let's say I want to ignore all of the contents in the results folder, but not the data folder inside of results. How do we do that? Very similar concept. We're going to say ignore all of the results, everything inside the results file. Everything inside the results folder with the asterisk at the end. That means everything that's in there, but not results/data. Do not ignore that folder. Okay. So I want to ignore. I've got all these files saved in these directories. I want to ignore all the .dat files. I don't want to ignore the info.txt file, and they're all saved in results/data/position/GPS. Can someone tell me what you would add to your .gitignore if you want to ignore all the .dat files? Maybe someone could put it into the chat if you've got an idea. Yep. So Adam's got it. Because you want to ignore all the .dat files, you can just do the asterisk.dat. I see that Mohammed has also said a similar thing. So you want to ignore all the .dat files in that directory. All you need to do is asterisk.dat. Okay, and it will match every file in that directory that ends with .dat. Info.txt does not end with .dat, so it will not be ignored. Okay. Again here, how do you ignore all the .dat files regardless of where they're stored? You can do ****dat, and that will say ignore all of the .dat files regardless of which folder they're in. Okay. So hopefully you're seeing how this works now. If you had something like this, which was ****dat and then not ****dat, what will happen? What do you think? Does anyone have an idea? What would be ignored as a result of this? Yeah, nothing's going to be ignored, because first of all, I'm saying ignore all the .dat files, and then I'm saying do not ignore all the .dat files. So nothing is going to be ignored, right? So the rules are ordered from top to bottom. So it's going to take this in a sequential chain, ignore all the .dat files, but do not ignore them all, right? So let's say you have a couple of log files, and they're all in the form log1, log2, log3, and you want to keep them in there, but you don't want to track them, right? So you can write .gitignore to exclude anything that has log and then any number after it. But let's say that, okay, you have decided that log1 is actually very important and log2 and log3 are not. So what could you do there? There are two potential answers. Yep, you could do not log1, and there's also one other answer. Let's say you really wanted to keep log1. What else could you possibly do? Okay, so git add, and then you force it, even though you've told it already to ignore. So we've got a question here. Okay, so if you wanted to ignore all the .dat files in one folder, so if you had the .dat files saved in results, then you could do something like this, right? If you wanted to ignore, if inside results you had a bunch of folders, each of them having .dat files, and you would do something like this. Oh, excuse me, that's wrong. Now, just so if we're looking at the git.gitignore file, but we also have the configuration file .gitconfig. And that, as you saw at the very beginning, that's where you keep all of your configuration that you set up with gitconfig global. Okay, so this is what it might look like. So similarly to .gitignore, you can actually add them. You can add them to the staging area. And you can use that to generate specific behaviors in your repositories if you need them. So for example, we said with .gitignore, we wanted to create a scenario where all of our collaborators are ignoring all the same files. You can stage that if you want to as well. Okay. So just to recap, .gitignore tells Git what to ignore, and .gitconfig tells Git how to behave.